All right, let's keep going with some multiplication. Now, if you look at this is two binomials. The other one had a monomial, right? Just one term on the outside. So it was just a simple distribute one thing throughout the parentheses. Well, this time we have two things right here multiplied by two things. So this 5x is going to be distributed through both of these, and then the minus 2y will be distributed through both of these, right? But we have another way to learn how to do this. Remember that? What was the little mnemonic device? FOIL, right? First, outside, inside, last. So we can think of it that way as well. But still, it's just a basic distributive property if you want to think of it that way. Let's do it underneath it here. Is that all right? So let's do the first. So it's 5x times 3x, which is 15x squared. Don't forget the x squared because it's x times x. And then 5x times negative y, which is negative 5xy. Then the inside. Okay, so it's negative 2y times 3x, which is negative 6. You could put yx, but since I already put this xy, it doesn't make any difference what order that goes in. So I'm just going to write that as xy, just to make sure they look the same. All right, then it's negative times negative, which is positive 2 what? Y squared. Now, do we just leave it like that and circle it? No, we always look to see if there's like terms. Are there any like terms here? Absolutely, the two in the middle. All right, so those are like terms. We've got to add those together. So we keep this the same. Now remember, when we add like terms, we just add the coefficients and keep the term the same. So it's negative 5 minus 6, which is negative 11. My term is xy, so I just keep it xy. I don't add any exponents here, do I? Because I'm just adding like terms. And then plus 2y squared. Any like terms now? Nope, we took care of them all. And there it is, just like that. It's not too hard, is it? Pretty easy. Okay. Now, number 9 is a little different. It's a binomial times a trinomial. So if you understood this distributive property for this, it's the same kind of deal with number 9. Okay, it's the same kind of deal, except I'm taking these two things times 3 terms here instead of just 2. All right, it's the same thing. So I'm not going to draw my arrows. It gets a little confusing if we've got too many of those things floating around. But I'm going to take 5x, multiply it by all 3 of these, and then I'm going to take 5y and multiply it by all 3 of these. You get it? So let's do it. So it's 5x times negative 2x. It's going to be negative 10, what? X squared, right? Because x times x to the first times x to the first, you add the exponents, so it's x squared. Then you take the 5x times this thing. So it's minus 35, what? Xy. Then you take the 5x times this, just plus 5x. All right, so we took that first one, we multiplied it by all 3 of these, you get 3 terms. Then you take the second one, you multiply it by all 3 of these. So let's do the same thing, but we're doing it this time with 5y. So 5y times this is negative 10. And yeah, we'll write it as xy. You could write it as yx, but why do that? You know, I like to keep them looking the same. Let's see, what's the next one? 5y times negative 7y, which is negative 35, what? Y squared. Okay, because y times y. Then we take 5y times this, which is plus 5y. All right, there's no more distributing to do. Are there any like terms I can add here? Let's always look to see if there's like terms. Yeah, the xy's, so I can add those. What about x squared? Is there any other x squareds? Nope, so I just write negative 10x squared. Let's go ahead and add the xy's. It's negative 35xy minus 10. So negative 35 minus 10 is negative 45. And then what's my term? It's just xy. All right, you don't add the exponents, do you? You just add the terms together, and it stays xy. So look, I'm done with that, I'm done with that, I'm done with that. Are there any other like terms to add? No. And it doesn't matter what order you put it in. Let's just keep it in the order that we've already have it written. This may be a different order than they read off. I can't remember. But that's perfectly fine like that. I don't really care what order you put it in. All right, and that's your answer. Make sense? Again, it's just a distributive property. It's adding like terms. Within the distributive property, you got to know the rules for exponents, right? When you multiply same base with exponents, you add the exponents together. So there's several rules that come into play on this problem. Just got to keep them all straight. All right, let's go to another one. All right, here's another multiplication one. Now look, let me show you a common mistake. I almost hate showing you the common mistake because because people sometimes make it, but try to keep it straight, all right? A lot of people will do this. 7m squared, 49m squared, plus 4 squared plus 16. So my answer is 49m squared plus 16. Is it? No. You would be, if you did that, you would be distributing exponents. There is no rule for distributing exponents. It doesn't exist. It doesn't work, okay? You can't just take the exponent and distribute it through both of these things, all right? You cannot do that. So when you square something, this is how you want to think of this. When you square something, what are you doing to any number? If I take a number and I square it, you're multiplying it by itself. So what I want to do is I want to write this, so I take that parentheses and multiply it by itself. See that? You must write it like that, okay? Unless you remember, there's like a little rule, a little trick to do this, but I would suggest that you write it out like this. And then you just do the FOIL method or distributive property just like we've always done. So we get 49m squared plus 7m times 4, which is 28m, plus inside of here, which would be what? Plus 28m plus 16, right? 4 times 4. So it's 4m squared plus, what's that, 56m plus 16. And that's all there is to it. Now, when I said that little trick, you could have done this. You could have squared this, squared this. What's that?
You mean 49m squared?
Where did I put?
Just squared.
Oh, yeah. You should have stopped me way back then. Absolutely, 49. Did I say 49? I don't know. We could check the tape, couldn't we? It is 49m squared, okay? All right, because I know 7 times 7 is not 4. All right. What's the little trick, though? You could go 7m squared, which is 49m squared, and then square this, which is 16, but you need a middle term. Without doing all this, how do you figure out the middle term? Multiply these together, which is 28m, and then do what to it? Times it by 2, right? So if you wanted to go that way, you could, right? That would be a little quicker if you remember the rule. But there's a lot of rules to remember. I'm not assuming you remember that rule. To play it safe, I would just do it like this, okay?
You can kind of do what I do, like,
Yeah, you could.
I just kind of do the motions, but in my head.
Right. But on a homework, though, I want to see your work. On a test, I'm not that concerned about seeing your work, okay? If you can do that in your head, then go ahead. More power to you. All right, let's do another one. Another binomial times a binomial, but just a little bit different. And this one, there's a kind of a little trick to it as well. All right, both of these, 10 and 11, to make things go a little bit quicker for you. All right, look at this thing right here. They kind of look the same, don't they? But it's not like this. This is a perfect square, isn't it? All right, so the perfect square says you square this, and then to find the middle one, you multiply them together and multiply it by 2, okay? So look at this one right here. I can multiply together 5a times 5a, and then 2c times 2c. But what happens to the outside and the inside here? Just in our head, let's look at it. It is FOIL, but look what happens, though. If these are exactly the same, except this is plus and this is minus, there's a little trick, so you don't actually have to go through the whole FOIL. That's right. The middle will always add up to 0. All right, do you see that? So look, this is going to be negative 10ac, and this is going to be positive 10ac, and what happens there? That's a 0, isn't it? All right, so that's kind of like a little shortcut, I guess, right? If you recognize it and look at it and say, oh, yeah, that's that difference of 2 square thing, I know my middle term is going to add up to 0, so I don't even have to worry about doing that. All right, so it's just 25a squared. It's always minus, right, because this times this is minus 4c squared. And you say, well, what happened to my middle one? Well, they added up to 0. I already knew they would, because when I looked at it, I recognized it, and then you can just leave it like that. That's a little nicer and quicker. Don't you agree? All right. All right, I think we're done. Hopefully we'll be able to finish tomorrow up to number 20. So we didn't do that binomial expansion one, but yeah, that should be pretty easy. Are you getting that?
Yeah.
Okay. All right, so we'll hit the rest of it tomorrow.